to. It's currently about 10:30 at night, and I have yet to actually start working on the actual streaming part of my plan of doing this daily study thing. This is about how I usually work, though. I remember back when I used to do math group a lot, I would always have this idea that I'm like, okay, cool. I'm going to this week, the week before, I will, do a blog, let's say. I got to be working on these problems, and so I might as well do this and share it with everybody. And the first day that I do it, it's like, oh, that went really well, and I did it at a reasonable time. The second day starts to push really, really late because of so many excuses I have of well, I'm working on the problems and I'm just doing all this stuff, and I just end up pushing it really late. Day 3, it will turn out I will sit there and it will be 9 o'clock, it will be 10 o'clock at night, and I'll be like, nah, I just really have zero desire to do this. I'll do it tomorrow. And then it never actually happens, and I've really only worked on 2 problems and shared it with 0 people. Yeah. So that is my fucking life right now. That's just how I operate with math group, and I'm glad to see that nothing's actually changed in the last couple years of me not doing this. Okay, so I'm just trying to find a good setup for this stupid microphone at the moment where it's in a position where I can actually, there we go. I actually like that because I need to be able to see what I'm doing, but also lean into the microphone so people can hear me, or so I can hear myself, because nobody's watching this. And if I don't actually look at my chat, my viewer log, then I can see that nobody's actually watching me, because yeah, I haven't shared this on Facebook yet, because who the hell cares? Anyways, so no, here's the actual funny story that's happening today. Is I discovered today that I've been spending the last 2 days and a good portion of today working on the wrong problem. So yesterday I kind of mentioned, I think yesterday when I finished, I read question 2 in the Philadelphia Math Counts meetup thing. And I read question 2 that showed us that at least 2 of them were the same month. What are the pigeonholes? Because we're working on the pigeonhole principle. And I read it and I go, oh, well, that's the birthday paradox, I'm pretty sure. So I look at the birthday paradox, and I look at the birthday paradox, and it's the idea that if you have a class of students, if you have a class of 23 students, the probability that 2 students have the same birthday is 50%. And then as you get closer and closer to, I believe it's 70 off the top of my head, it's 100%. So I was working on this all day, and I was working on different parts of this, and I was like, okay, this is cool. But as I'm working on it the entire time, I'm just thinking, I'm like, this is really weird, because how, am I supposed to prove this? What am I supposed to do for this? Because I'm watching these videos by Maiyu Chung, and it's just man, why are you talking so much about set theory? This is blowing my mind. So finally, around 8:30, I think, 8:30 at night, a couple hours ago, I finally just go, it's okay, well, let's dig through this a little bit, and discover that, no, I was watching the wrong videos the entire time. I was watching stuff on I think, inclusion theory, and it turned out that it was not useful. It was not anything that needed to be done. All I really needed to do is what I can show you today, what I'm doing. And that is, if we have 30 students, so the question, of course, is with, come on, oh, it's on erase mode. Okay. The idea is that if we have 30 students, 30 students. What and we want to prove that out of 30 students, at least 2 will share the same birthday. How do we show this? Using the pigeonhole principle. Of course, pigeonhole n items are put into m containers with n greater than m, and at least one container must contain more than one item. Using this idea, the next question is about birthdays, and it's completely stupid simple because 30 students. So then the question goes like, what are the pigeons and what are the pigeonholes? Because of this whole part of the video where she has this animated thing about pigeons. Whatever. Basically, we want to divide up 30 students into 12 months. Is the idea. And I am so silly for just like I said, I spent my entire day dealing with like, like how do I present myself was like, I think the first few hours was like, how do I present myself on this thing, because I liked, because of the swearing, and then the whole thing about yesterday about butts into butt plugs, which I still think I peaked. Like, there's no reason to actually do this anymore because that's just like the greatest thing that I'm ever going to come up with. So I spent this entire time trying to figure out the principle, and I might do it. I don't know yet. This is really simple because, hey, prove that at least 2. Well, the thing is like, we only have 12 months to put 30 students into. So even if we were to try to divide it up evenly, we could just simply see that 12 times 2 is 24. So you can divide up. You could have 2 students per month. I'm just get used to this stupid tablet. I think I just need to figure out how to 2 per month, right? Per is actually this guy because I'm wrong. Okay, it's actually 2 per month, right? And then you're still gonna have 6 students left over. This is just like, I'm just so annoyed with myself that like it took me a day to figure out that I'm just dumb. That I am just dumb. This isn't like, I'm sitting here going, it's like, how is set theory going to go into this entire thing with the birthday paradox? Like, it's not the birthday paradox, you dummy. The entire question is just put 30 students into 12 months. Like, well, that means you just get 2 students you can put 2 students per month with 6 students left over. That's all you have to do. And I mean, there's cool ways that we could do that. We could do that, we could animate that actually. We could like, we could make boxes. We could make little boxes to animate with, and then we could just have students. And then we could just put students, we could just like cram students into boxes in like increasingly violent ways, or not, whatever. Put cats in the boxes, I don't really know, we could put anything. And then after you get to the 12th, you'll be like, look, hey, we still have 30 minus 12 students left over. That's 18. That's 18 students. We have 18 students left over. I'm sorry. I just hate myself that it took me this long to figure this out. So let's see if I can just redeem myself, maybe, and figure out this next problem in a shorter amount of time. I'm going to say no. I'm going to say I'm going to start to work on this tonight and probably end up working on it tomorrow because it is fucking 10:30 and I gotta go to bed soon. So I can wake up in the morning. So given a pair of 10 blue socks and 12 pairs of white socks. How many times must we pick a sock at random to get a pair of the same color socks? So we have, so this is something I find really fast, which I really like about these Mayu Chun videos on edX. I'm going to mention this because I was thinking about it. It's like she does a lot of combinatoric problems, but like a lot of the stuff they'll do is actually just like really simple stuff that you've done before. I remember she did an entire video, or she did a few series on the Towers of Hanoi, which is a problem that a lot of people are going to know, but it's fun because like how did they do that? They did it with I think they did it with Power Series, if I'm remembering correctly, and it was just a crazy way of doing it. So we're going to do 10 blue socks. Pairs. So 20. And then we have 12 pairs of white, or 24 white socks. Okay. I'm not really sure. Okay, like for some odd reason, this, I think the dual screen up a little bit, because every now and then my entire operation just goes to a different screen. How many times must we pick a sock at random to get a pair of the same colored socks? Yeah, I can't think about this right now because, like I said, I'm an idiot. So there's something to think about, and I'll come back at some point later tomorrow. I'm not dumb. Peace.